Okay, so real quick, I'm gonna let you guys work today. I want to remind you about something. So let's get your notes out. Let's get going. Take 5 minutes, and then you can go. You can work.
If I had local, I would have gotten like 70.
I still have Mr. Ware,
Yeah.
when I get on like the Chromebooks here, the 1.1 and 1.2 don't show up. They keep like showing up and then they won't show up, and then they'll show up like sometime later and then they don't show up.
On the Chromebooks?
Yeah. Like yesterday they didn't show up, but then I went to John last night and then they showed up on his computer.
It's weird.
Yeah.
So that's, I mean, don't. So you've already done them.
No, I haven't done them because
Oh.
I got on and then they wouldn't show up, and so I was like, okay.
Oh, you know what it was yesterday? Okay, I just extended the deadline out again. I think I don't want to do that anymore. I'm just gonna from now on. I'm just gonna like whenever the test is gonna be, like a week after that. I'm just gonna make every assignment open till then, and I'll put it in the grade book way sooner. I just had to, you know what I mean?
Yeah.
That's all it was. Okay, here we go. All right, attention please. Okay, I don't think I'm going to record this. I don't think I need to. I'm going to give you this little handout here in a second anyway. This one kind of will supersede the other ones that I gave you about transforming functions. I just want to make sure everybody's on the right page with that. You guys, I want you guys to be able to do this at a little higher level. So if we want to ever, if we want to transform, what the heck? Okay, hang on one second. All right, so okay, so if we want to rewrite, we want to rewrite the function, the parent function f of x, and we want to transform it. There's a bunch of stuff we can do. What do we do to translate up? K should be positive. Translate down. K is negative. Gotcha. Translate right. H is positive. Translate left. H is negative. Remember, H is the number that is being subtracted from X, right? Does that make sense? So more broadly speaking, then it's really easy to go up and down. All you do is add a number to a function. But if I'm starting with like, let's say a harder function. Let's say this is our original function. Say we've got something like f of x equals 3x cubed minus 2x plus 4. And I want to translate that whole function to the left by 7. What do I do? So I'm not sure that the way that this isn't the way I would have always necessarily taught this, the way the book did. This might be helpful to you to hear a little different approach to this. Does anybody know what we would do there?
No.
Really, all you're doing is you're taking x and you're replacing x with x minus h. Every place there's an x, right? So if we want to translate this thing left by 7, what should the value of h be? Negative 7. So then every place I had an x, I'm now going to have an x plus 7. You see what I'm saying? that translates it left. Okay? So that's all we're doing. We're substituting an x minus h for an x. Okay? Does that make it easier? Okay. If we're technically, if we're translating up or down, what are we really doing? We're really just substituting a y for a y. Like we want to go up by 7 with the same function. Say we started with f of x. We want to go up 7. What are we doing? We're really just substituting y plus 7 for y. Well, what's y? F of x is y, right? So that's why that whole thing right there is y, right? So all we're doing is we're just trading plus 7, this thing for this thing plus 7, because this thing represents y. Does that make sense? So you can think of it kind of in the same context. It doesn't change what you do. I mean, moving things up or down, you can do easily. You're just adding a number to the whole thing, right? Or subtracting a number to move it down. But does that make sense that it really is the same idea as what we did here? We're just substituting y plus 7 for what used to be y. If we want to go right by 7, we'll substitute x minus 7 for all the x's. Okay? Make sense? Okay, what if we want to stretch vertically? What do we do? What do we do if we want to stretch vertically? It's A, yeah. Really all we're doing is we're multiplying y by the stretch factor, right? Does that make sense? Well, what's y? This whole thing is y, right? So if I want to take this function, for example, and I want to do that to it, right? I'm going to multiply by a bigger than 1. What am I going to get? So g of x, my new function, is just going to be that whole thing times, how much did I say we're going to stretch it by? So we stretch it by 2. It's just going to be 2 times that, times the whole thing, right? Whatever f of x was, that's y. I'm just going to multiply it by 2. Make sense? If I want to shrink it vertically, maybe I make that a 1/2, shrink it vertically, right? We good so far? Okay, what about to stretch horizontally? Okay, that's B, isn't it? Right? So compress is obviously we did that. Stretch horizontally, B is going to be greater than 1, right? So what does that mean up here then? What's B? B is just the number in front of x, right? So what would we do if I want to stretch this thing horizontally by a factor of 2? What am I going to do? What am I going to substitute for all of the x's? Think what I substituted. What did I do to stretch vertically? I substituted 2 times y for y, right? To stretch vertically, I let y become 2y. I multiplied the whole thing, which is y, times 2. What am I going to do to stretch horizontally? What am I going to replace the x's with? Okay, but remember, b's on the bottom, so it's going to be 1/2 x, right? Make sense? So this would become then, if I'm going to stretch horizontally, this would be like saying f of 1/2 x. That's all I'm doing. I'm replacing the x's with 1/2 x's. So it would just become 3 times 1/2 x cubed minus 2 times 1/2 x plus 4. Now this is a way harder function than the ones that you were given in the little assignments. They never had multiple variables appearing or anything like that. But I want you to kind of see, so you guys can know at a little higher level, this is really what you're doing, right? When we substitute for b, all we're really doing is we're making a trade, right? We're going to take all the x's and we're going to change those x coordinates in that way. Okay? Make sense? What if I wanted to compress vertically by a factor of 3? What would I do? Or compress horizontally, sorry. What would I replace all the x's with then? Yeah, good. All the x's would just get replaced with 3x. If I want to compress by a factor of 3, right? 1 over 1/3. Okay? Okay, now what if we wanted to reflect over the x-axis? What am I really doing if I reflect over the x-axis? Which variable, if I'm reflecting over the x-axis, I want to reflect that point over the x-axis, which coordinate is being changed, the x or y?
Y.
And what are we doing to the y coordinate? Yeah, okay, yeah, we're taking its opposite, right? So really all we're going to do if we want to reflect over the x-axis is we're going to multiply y by -1. Make sense? So if this is my original function, what do you suppose I do to that function to flip it over the x-axis? Okay, but yeah, you're right, but this whole thing is f, right? Everybody agree? Like this is f of x. So what am I going to do to this whole function? Multiply by -1, because it's y, right? This is y equals that. So I'm going to multiply the whole thing by -1. So in our case right here, then it would just look like g of x equals negative that whole quantity. I could distribute, right? Okay, makes sense? What if I want to then reflect over the y-axis? Think if I reflect over the y-axis, which coordinate am I changing? The x, right? So what am I going to do then, I suppose? I'm going to multiply all the x's by -1, right? So in other words, we're just replacing the x's with negative x's. That's the way to think about it, right? So we'd end up with g of x equals 3 times -x cubed minus 2 times -x plus 4. And I can simplify that, but that's the transformation. Make sense? Okay. That's the way I'm used to teaching it. I want you to be able to reconcile this with what the book does, but that's how I would look at it, for example. Okay, 'cause I know you can still do the assignments in the book, kind of just using the book's template, and that's fine, but I want you to be able to do some harder stuff, and so this is how you kind of have to think about it, I think. Does that make sense? Okay. The other thing that came up a little bit that I thought people had a little trouble with, and I get it, was like there were some questions in the last couple assignments where they gave you, I think, like an area function. Area is a function of height. Remember that one? They want you to find the inverse and the domain of the inverse and all that stuff. Let's just look at one like that for a second. What if we've got, what if we have something like area equals, oh, I don't know, what's area equal? Area equals 10 times height, something like that. It's just say it's the area of a rectangle with height 10 or something, or with width 10, something like that, okay? They want you to write the inverse function, they want you to write the domain of the inverse function, stuff like that. Well, in this, the way this is written right now, what's my input variable and what's my output variable? Input is h, output is a. Okay, so we could write this as a as a function of h if we wanted to. A of h equals 10h. So then what's my domain? What's my domain here? What are the values of h? Now this is a geometric situation here, right? We're looking at something like this. Say we've got rectangles of width 10 and height h, right? So what makes sense for a domain? Could I have an h with a value of -7?
No.
Wouldn't make sense, right? So, and we could have an argument here. I believe that's right. The book, they tend to include the 0 in there, which is fine, I guess. You get a rectangle of height 0. It's up for debate. I mean, it kind of depends on your That's what I would say too. That's what I would say too. But either way, if we say that the domain is well, they said just greater than 0. So h is greater than or equal to 0. So if h is 0, then your area shrinks to 0. Fine, but it can't be negative, right? So what's the range that goes with that? How are we going to find that? Well, if you think about those values of h, inserting those values of h into my function, what values of a would be the output? Like, for example, if I plug in 0 for h, what do I get? I get 0 for a, right? If I plug in any positive value for h, though, how would you characterize the answer? It's going to be positive, right? Okay. And we could go up by any increment we want to, but we know that ultimately this is going to be the range, right? So if we want to solve for the inverse function here, what's the point of that? Well, the point is, in real life, the point is really all we're doing is we're just going to solve for the other variable and let that become the dependent variable, right? We're going to isolate h, in other words, right? Why is that useful? Who knows? Maybe we're going to start with these rectangles and we want to be able to predict based on the area of the rectangle what the height is for whatever reason, right? But it's convenient for us. So we're just going to turn this around. Well, to solve for h, what do I have to do? To both sides. Just divide by 10, right? No big deal. So then we could turn this around and write this as h equals a over 10, right? Okay, but if we do that, when we calculate an inverse, what are we really doing to the domain and the range? What do we say the definition of an inverse really is? Just switch the domain and the range, right? So we don't even have to really think about this. What's going to be the domain of my inverse function? What's going to be the range? Okay? So if you want to calculate, in other words, if you want to calculate the domain of an inverse, you might just as easy calculate what? If you want to calculate the domain of an inverse, you could just as easily calculate the range of the original function, right? And that's guaranteed to be the domain of the inverse. Okay? Does that make sense? I'll give you one really important example of that. And then I'll be done. You can work. I tell you what, you guys have, I heard you have lots of tests Wednesday, is that right? Raise your hand if you...
Wait, we do have tests on Wednesday?
Well, that's what people are saying, is that right or not?
Yeah.
Raise your hand if you've got tests on Wednesday.
We have tests every day.
Not counting mine, I mean. Who has tests on Wednesday, not counting mine?
I have like each day.
I probably
I
do.
don't know. I don't remember my classes.
I want to go home. That's what I know.
Who has tests, and we have tests on Thursday this week, other than
I
mine.
have tests every
Yeah,
maybe.
pretty much
If
everything.
Tuesday's a good move, we'll have it on Friday.
So, I mean, if that happens, I'm fine just moving it on. I don't care. I mean, is it better to do it Thursday than Wednesday? You have lots of tests on Wednesday. Okay, that's fine. So we can do it. We'll do it Thursday. I'm fine with that. Well, I'll tell you in a second. Okay, let's look at this situation. What if we have? This is. God, I should record this. Probably should.
What happened to 5 minutes?
Yeah, it's got a little longer. Oh, I did record. I think I was recording. Never mind. So what about this one? What if we want to do? Hold on. What if we want to do the inverse of the function y equals x squared? Okay. So there's my original function. F of x equals x squared, right? Okay, if I want to find the inverse, this is good review also, because the last assignments, the ones in 1-4, deal with inverses, right? So what's our recipe for finding an inverse?
Change it to y.
Okay, first step is change it to y. Next step, switch x and y. So I'm going to make it red, so now we know that we've made the transition. And now next, I guess, almost last step. Say it again. What do we do next? We switch x and y, and then we solve for the new y, right? And that's going to be our inverse function. So what do we do to get the y by itself here? I got to square root both sides, but what's our rule for that? Remember? If I solve an equation by square rooting both sides, what do I have to include? Plus or minus. Yeah, plus or minus. And remember, I think I told you guys why that is, right? Technically, the reason we do that is if I've got y squared equals x, and I square root both sides, I get the square root of y squared equals the square root of x. And what's our definition of the square root of something squared? Think what that does. If I put in a negative value and I square it, it becomes positive, and so the square root becomes positive. Right? Like if I put in a negative 3 squared is what? 9. Square root of 9 is? What function does that? Makes it positive. Absolute value. This is the definition of absolute value. And if the absolute value of y equals x, then that means that y could really equal plus or minus square root of x, right? You don't have to show that work every time, that's fine. You just have to remember, though, that when I solve an equation by square rooting both sides, I have to put in a plus or minus. Supposed to be an x, yeah. And then finally, we just write it as an inverse, right? If we want to. Okay, so we get plus or minus the square root of x. Now, if I graph that, what's that look like? What does positive the square root of x look like? You know? We'll talk about it more this year. Tell you what, it looks like this. What does minus the square root of x look like? Well, what happens if I multiply a function by -1? It's reflected over the x-axis, right? So there's minus the square root of x. Makes sense because if you combine both the red and the green, they have the kind of symmetry that we need, don't they? They have reflective symmetry about the line y equals x. Agreed? Okay, but what do you notice here? You notice that the inverse violates the vertical line test, and the math gods are pretty smart. They told us that. Because when they included the plus or minus, that meant they had to break it into 2 pieces. It's really, math just does this. It's so consistent. They have to break it into 2 pieces so we can think of it as being functions individually. If I take just the red piece or just the green piece, they're fine individually, right? But together they violate the vertical line test. Okay? So think about this then. If I want to think of the blue function as having an inverse function, I would have to go back and trim it a little bit. Which part of the blue function goes with the red inverse function? Goes with the red part. That would be the right side, wouldn't it? That's the one that's reflected over. So this guy right here, he's going to go with the red part, and then the light blue part goes with the green part, right? Does that make sense? Okay, look what happens with the domains and ranges. This is interesting. We'll come back to this stuff again when we talk about quadratics. I mean, but I want you to see this. Now is a good time to kind of get introduced to this, I believe. So what's the domain of f of x? The blue function. What's the domain of the whole blue function? Is there any restriction on the domain? No. Just goes forever, right? All reals? What's the range? Y is greater than or equal to 0. Everybody agree? Okay, so like that. Does that make sense? Okay, let's take just the red square root function. If I take just the red square root function over here, what's the, so we get f inverse equals the square root of x, just the red one. What's the domain? Greater than or equal to 0? Okay, that fits, doesn't it? Because look, the domain and the range match up, right? What's the range of the red function? What's the range of the red function? Greater than or equal to 0, right? Well, wait a second. That doesn't match up with my original domain. But it shouldn't, right? Because the red square root function only goes with the right half of the original function. Does that make sense? So if I want to know what part of the original function is going to, by itself, will produce an inverse function, I've got to take what I get for the range of my inverse and go back and artificially kind of trim the domain of the first function, right? If we make this one go from just greater than or equal to 0 and just get rid of this part, then that works. The blue and the red go together, right? Okay, what's the point of that? It kind of shows you that the two work in harmony. You can't just, if we're going to talk about a function and its inverse, you have to think about not only the domain and range of the function, but also the domain and the range of the inverse, because they have to be interchanged, right? So if we want to write the blue parabola, if we want to break it into a piece that has an inverse function that's 1 to 1, we only can take, for example, either just the right piece by itself or the left piece by itself. Okay? Kind of get it? Okay, that's a lot of work. I'll get the Chromebooks. You guys can work. I'll let you finish up your hour tomorrow.
Yeah, I'm just gonna ask you.
Yeah, I have to work on my poetry. There's some emails that were false statements. I approve.
Are you ready for
Spoiler. I know. A quarter a day. 6 days away.
Just say Halloween.
Yes.
Oh, God, yeah.
He's gonna be like.
Like, crazy days. I think they should allow us to wear.
Gotta put it up there.
It's super easy.
Okay, if you go to Moodle, go ahead and grab a Chromebook. If you go to Moodle, I'll show you where they are.
Yeah. Sure, it's not.
Okay, we'll get them. Come on up, we'll get them set up. So if you guys go to Moodle, you go to Honors Algebra 2, you'll see under Unit 1 Practice, there's just some additional assignments. You'll like these. These will look familiar to you. There's no limit to how many times you can try questions. I kind of think they're better questions. So you'll write the domain like as an inequality using the algebra editor, etc.
Can we just tell them that we've already used the whatever other site and we can just switch back to this? We gave it a try.
We'll supplement heavily. How's that?
Wait, should I just come up here?
Yeah, let me get you accounts. All you have to do with your Moodle account is just go to, it's already set up. Yeah, you just have to just go, update your profile. So you go to,
I don't think I'm logged in.
oh, go ahead and log in. Yeah.
Say it next.
Yeah.
Maybe that's what I love. Oh.